Hi, Shai. Welcome to the Satellite Image Deep Learning podcast. How are you?
Hi, Robin. It's great to be here.
Fantastic. Now, you are working on the MAFAT challenge. Is that correct?
Yeah, that's correct.
All right. So, do you mind giving us a brief summary of this particular challenge? And also, then we could talk about your involvement in the challenge.
Yes, of course. So the MAFAT challenge it's a series of data science competitions. It ranges from object classifications, mostly from satellite images, to detecting how many people are in a room using Wi-Fi signals, and analyzing radar signals to identify if the radar picked up a person or an animal. And it's a variety of challenges in the data science domain. And the current challenge that we have on is an object detection challenge from satellite images. The MAFAT challenge is the set of competitions are organized by the Israeli Ministry of Defense, and I'm part of a company named WebX. We are the contractor that operates these competitions, and that's it.
Right. So, I guess to play devil's advocate, object detection is a problem people have been working on for years. Why run a competition on it?
Okay, so mostly the object detections repositories and articles you read are based on common day objects. Forward-looking camera, identify a dog in the image, a person. It's a very common to see these things in the automotive industry, like detect cars, street lights, stuff like that. But from the object detection in satellite imagery is far less common. And the problem is a little bit different. Because you're observing the Earth from above, objects can be rotated. There's various resolutions, and the cameras are more advanced. Some cameras have more
More pixels?
more pixel, larger images, and more color channels. So the whole imagery is more complex, and it's not a solved problem. It's a fact that you try to detect objects in satellite images, and it's not that easy.
Yeah.
Everyone jumps into it, says, "Oh, I'll just take the most recent version of yellow and it will work," but
Right.
it doesn't.
Yeah. Or it works, but the performance is,
Yeah.
unsatisfactory. Right. And in this competition, you chose to use rotated bounding boxes, which again is not sort of typical. Can you discuss the reasoning behind that decision?
Yes, of course. Let's say we're looking at the common use of object detections. So we have a forward-facing camera on street level, let's say. So all the objects, well, most objects in our world, they are placed on the ground and they are perpendicular to the ground. So when you take an image of them, you usually use the camera parallel to the ground. So when you take the image, the object is mostly aligned with the image. That means that, like, if I try to define the bounding box of the objects, it matches the image grid, the pixel grid, you could say.
Mhm.
But now let's look at it from a satellite perspective or even a drone perspective, any downward looking camera. Now our objects can be rotated, meaning if I try to apply the same principle of having a bounding box that is aligned with the image frame, the pixel grid, I'll have just detecting, let's say, a long, thin object. I'll have a lot of, and if I drew the bounding box around it, I'll have a lot of area that is not part of the object, but is still labeled as part of the object.
Mm.
So if you place a rotated bounding box around this object, you'll get a more tight bounding box that is just defining the object itself.
Mm-hmm. And is the hypothesis that rotated bounding boxes will result in more accurate solutions, or it's more about the practicalities of generating a rotated bounding box?
It has to do with both. I mean, it depends on what you're trying to achieve with your model detection. I mean, for small objects, let's say cars, I don't think it matters much because you usually just want to know how many of those are there. But if it's a different object, let's say a large vessel, like a large boat, and the direction that the boat is facing is also very important sometimes. You want to know where it's going, where it came from. So the direction is important, and having it precise helps.
Yeah, absolutely. And you can do some kind of measurements on the size of the boat, for example, that you couldn't do with just a regular bounding box. Really interesting point. Yeah. Okay, I think you've got a short presentation on this particular challenge. Should we take a look at that?
Okay, so the MAFAT challenges competitions are a set of challenges that we have been hosting since 2018. The current challenge is the satellite vision, which is an object detection challenge. But I'll review a bit of the previous challenges we had. So all the challenges have prize money. So it's like if you win, it's really nice. You get a few $1,000s. But you can learn a lot from just participating in data science competitions, similar to the ones you have on Kaggle and stuff like that. So the first challenges we hosted was back in 2018. It was fine-grained classification of objects from aerial images. It's kind of similar to what we have now, except there was we skipped the part of the object detection. It was just classification. Okay. Images were taken from a downward-looking camera. We had the vehicles themselves. They were we labeled them and then gave the participant just the crops, so they could look and classify just the cars. And that was back in 2018.
And that's a technique that I guess predates modern object detection models.
Yeah, we just wanted just classification. I mean, you didn't have to detect where in the image it was. So what you fed to your model wasn't the whole image. It was just the small part of just the vehicle itself. So smaller images. It's a bit of an easier problem than object detection.
Yeah.
The next challenge was distinguishing between humans and animals in radar signals. That was back at 2020. It was a fairly difficult challenge because the images you get weren't exactly images. They were something like what you see on screen right now. And from this signal, you had to detect if it was you have to distinguish between humans and animals. Then
that one was treated as an image classification problem, was it? By the winners?
To be honest, I don't know. I mean, you might want to edit this one out. This is before I started working.
Right, okay.
I don't know. Yeah. Okay, the next challenge we had was last year. It was the Wi-Fi challenge. The goal in this challenge was from Wi-Fi signals to detect if a room has a person or not in it. You might say, oh, what's the problem? Just check if there's a device connected to the router. But the whole point was to do it without having a device connected to the router, just by the interferences in the router signals that are caused when someone is in the room. It was a fairly difficult challenge. It had two. The competition was divided into two tracks. One was just detecting if there's a person in the room, and the other was people counting how many people were in the room from 0 to 3. And I think that at the end of the competition, it was pretty clear that you can detect if there's someone in the room, but to count how many people in the room, it was very difficult, almost impossible.
Right.
It was a very interesting competition. Here, the signal were just a sequence of RSSI signals from the Wi-Fi. For anyone who doesn't know, RSSI is it's this. You could say it's the signal strength that the router emits or receives.
Yeah.
Okay, and the current challenge we have right now is classic object detection in satellite images. But what's special here from other data sets that try to solve this problem also is that the images are they have lots of unique features. For starters, there's on top of the image data itself, we provide some metadata, including the image resolution, sun elevation, which affects the shadows in the image a lot, the azimuth of the image that it was taken in, and the sun azimuth. We hope for the participants to use these metadata to their advantage. You can use it post-processing or maybe feed it to the model during inference. Lots of possibilities. It will be interesting to see how it's done.
Yeah.
There's a variety of classes that we want the participants to detect, starting from small to medium, large vehicles, double trailers, and other kinds of vehicles, aircrafts, and containers. I won't go over all of them, but there's a few examples here in the images that you can see. All the bounding boxes are rotated. So it also adds another challenge to the competition. So because you have to adjust your loss functions, it doesn't fit the traditional classic way of horizontal bounding boxes. Another important thing, another thing is that the range of image resolution varies. I mean, it's pretty good resolution from 0.4 to 1.3 meters per pixel. I mean, it's pretty decent resolution, but it varies. Usually in competitions, you have a much narrower set of resolutions.
Yeah.
You can see the difference here. Okay, you can see on the left image, it's a truck, and you can see it pretty clearly. And on the right image, it's another truck, but the resolution is not as good. It's much harder to see what it is.
Yeah.
There's also a large variation between the objects themselves, even in the same resolution of image. Here you can see a very large vessel, and in the other image you can see a car, but it's much harder to understand what it is.
Yeah.
Finally, some objects are only distinguishable via context. On the left image, you can see those square white things. Those are buses, and you can understand that because they're on the road and it's inside a city. And on the right image, you see some other square white things, rectangular white things. But you can tell that they are containers because they're in some place that looks like a dock or something like that.
Yeah.
Also, there's a variety of the scenery. There's dense cities and empty deserts and everything in between. And one last thing, which I think I haven't seen in any other satellite data set, is the direction of the images. Some of them are in the nadir direction from top-down view. Others are more oblique. It's not as common to see satellite images of those kind, and also makes the object looks very different. This is the same airfield, and the airplanes look completely different.
Yeah, you can almost barely see the wings at that angle, can't you?
Yeah, it's very hard to detect those. And we have discussed already the rotated bounding boxes. And finally, there's the prize money. It's pretty decent prizes. First place, $20,000, and all the way down to $4,000 for the fifth place. So there's a pretty good chance of winning. The competition will be held until 27th of April. We launched it February 1st, and we welcome everyone to try.
I think it's a really exciting competition, and I do agree there's quite a few novel aspects to the task. I'm really looking forward to seeing the solutions people come up with. I'm also really curious about the organization of the competition, like even basic stuff, like how do you decide how long it should last? I mean,
okay, that's a good question. Usually we just, in terms of length of competition, you check what other people do and you do something quite similar. You don't want to make it too long, because then people lose interest in between, and you don't want to make it too short, because you want to give people some time to build sophisticated things and go over the data and analyze it a bit. It's not that simple. And also a good indication is to see how long does it take you, like the organizer, to build something basic based off the data that you have. And I mean, it took a bit longer to us because you had to do it from scratch. We didn't even have the data at the beginning, just the idea of what you want to do. So we had to do some research. But we launched the competition with an analysis Jupyter notebook that participants can start from. So you don't have to start from scratch. And the baseline model that it took us some time to find, let's say, a convenient way to run the model, to run like a training and inference on this kind of data.
Yeah, well, that's really interesting. So I suppose if it had been twice as difficult, you might have said the competition should have longer to run because it's a more difficult problem.
Yeah, it is. It's very difficult. I think the time span we gave it it's pretty long, and it should be enough.
And what are the sort of parameters around team sizes, and like, what do you regard as like a reasonable entry? Like, if I could have 1,000 people employed working on this, would that be a valid team to enter, or are there sort of certain parameters that you look for to define a team?
To be honest, I don't have an answer for you for that.
Yeah.
I did that.
Right. But you've also got a forum where people can sort of share their progress, and, a public leaderboard where people can, demonstrate their progression on the task.
Yeah. At the end, it's a competition. So you want to get people motivated to do their best.
Yeah.
And we've seen it. Yeah, we've seen it in previous competitions. Like someone gets by another person with their score and gets to the lead. And then you start seeing, I mean, we can see the submission. Whenever someone is making a submission, we can see. And then you see the person that went down from first to second place start to submitting a lot more. And he's trying to get back to his first place. So the leaderboard has its effect. And I think it's fun for people just to see where they stand compared to other competitors.
Yeah.
Regarding the forum, it's more of a technical forum. If you have any questions, we respond pretty quickly, just a matter of hours, mostly a day at most, except maybe for the weekends, which it takes a bit longer. We try to keep it as active as possible. Mostly because we want people to succeed. We want to see new ideas. And if someone is getting stuck on some basic technicalities, it's in our interest to make sure they get by it and start trying their stuff.
I mean, there must be some really interesting dynamic. Like, you want to ask a question, but not give away too much insight into your maybe unique idea that you're working on.
Yeah.
Yeah, fantastic. So does that mean that somebody from the team is basically monitoring, this chat forum and, responding to comments, and it's quite a sort of full-time role to run a competition like this?
Yes. I would say when you run a competition like this, you can divide it into few parts. First, there's when you get the job, let's say from the whoever asked for you to make this competition, you first have to check, is it possible to do what he wants to do? I mean, sometimes people don't, were not part of the, say, the deep learning community has some fantasies about what AI can do. So you have to make sure that what they want is possible. This is before the competition even begins. Once you understand that it's possible and there's enough data to make it happen, you start researching how you solve the problem. Like what's the state of the art right now? How should do I need to label the data? Is it not? Is it ready? Is it not? And then how do I and which platform do I host the competition? That's also an issue. Once all of this is ready and the competition is in the air, there's maintenance, like you said, that has to be done. You have to answer questions. So we released a baseline model. So when we are people, we might have made some mistakes in it, entered some bugs. So sometimes you have to update the code that you released for everyone to use. Some people have problem with the submission. They try to run your model. It's supposed to work and it doesn't work. So you have to help them get it right. Yeah, once it's on, it's still a full-time job to maintain it.
Yeah. Actually, just another thought that popped into my head. Obviously, somebody could come along with a simple model that runs on a small GPU machine, and somebody could have a really complex ensemble. How do you kind of decide ahead of time where the model is going to be run, and how does that potentially influence the way people tackle the problem?
Okay, so there's a few factors in deciding that. First of all, there's a matter of costs. Since we provide a machine that runs the submitted models, this is a code competition. It's not a results competition. I mean, which means that you submit your inference code, and our machine runs it on the test data, which the competitors do not see at any point, and they only get the final score. So we have to have a machine that can run it. If we use a really strong machine all the time, it will cost a lot of money. So there's this is one consideration that you have to keep in mind. The other one is that you really don't want super heavy models that have no limit and they just crunch a lot of data and went like that. So we applied a few limitations on the which are mostly are done from the hardware. We used an okay GPU, let's put it this way, not the strongest one you have, and we limited the time that the code can run. So you can't waste a lot of time. It has to still be in reasonable amount of time, which is also something that whoever is going to use these models later on, it's also important to them. They don't want a model that takes 15 minutes to process a small image.
Yeah.
They want something pretty fast.
Right. Well, that's a really interesting insight into the decision-making process there. I guess that's the end of my questions. Are there any other points you'd like to raise on the competition?
I think it's a great opportunity for someone to try their object detection models. It's not that complex to take a model that is designed for horizontal bounding boxes and fit it to work on rotated bounding boxes, though it is a bit of work. But this competition presents, other than that, a lot of challenges. I mean, I think it would be interesting to see if anyone actually uses the metadata inside the network, feed it into the bottleneck of somehow or any other way. or maybe even use it in post-process to distinguish between, we saw that we have, let's say, cars. So there's a small car, medium car, a large car. And there's the definition of exactly which ones mean. I mean, in terms of real world size.
Yeah.
So you could probably use the metadata for post-processing. And that would be interesting to see if anyone tries any of these.
Yeah, no,
Also,
I do agree.
Yeah. I saw a few months ago, an interesting article from Google that uses an image captioning model to do object detection. The model outputted the detections as words.
Yeah.
I think that would be cool to try.
Yeah.
And there's a lot of ideas. I just gave a few. I'm sure we'll see interesting stuff.
Yeah, it's been a really exciting couple of years just because of, this sort of new sort of class of models that combine image and other data like text as well. And I think, as you say, there could be some really surprising entries to this competition.
Yeah.
Fantastic.
One more thing, I haven't discussed it. We also released a large amount of unlabeled data. So there's a great opportunity to leverage any self-supervised techniques or any other creative thing that people could do. And it's very useful.
Fantastic. Well, thanks so much for joining me today and sharing both the information about this competition and also the background and the thought that went into constructing the competition. I'll put the location of the competition website in the show notes, but otherwise I look forward to hearing the results and the outcome of the competition.
Thank you, Robin. It was great being here.
Thank you. Bye.
Bye.